Welcome back to day 10 of 30 minutes of problem solving a day. Today we are going to be doing the 2021 AIME II problem because you guys wanted me to do AIME problems. Now, just because the series hasn't been as popular as I thought it would be, and I'm starting a new internship like this week, and it's getting a little bit busy. I don't think I could keep making these kind of videos. I'm going to go until day 14, and then we'll call it a day. I also think you guys like the more edited versions of these videos a lot more, so I'm gonna stick with those, and if you guys have any suggestions, just keep leaving them in the comments, and I will do the edited version. I think these videos, like, even though they're easier on my editor, I don't think you guys enjoy them as much. So we'll do that. Okay, sounds good. But for now, we'll do the last remaining 5 days and call it a series. Very nice. Okay, 2021 AIME II. Oh, I forgot to open my Photoshop. Very nice. Give that some time, but we could read the problem in the meantime. Let me put 30 minutes on the timer. 30-minute timer. Alright, nice. Find the arithmetic mean of all 3-digit palindromes. Alright. Okay, that's it. That was short. Okay, I thought I was gonna ask for more. Okay. So, we'll make a new file. Alright. And we will move it over there. Very nice. Alright. Okay. So, we basically want to find an arithmetic mean of all 3-digit palindromes. So, basically the way you usually do these kind of problems is we want to find the arithmetic mean, which means we want to find the sum, right? Because it's easy to count how many 3-digit palindromes there are. And if you want to count the sum, then usually you count like the sum of each individual digit, right? You find the sum of the hundredth digit, multiply that by 100, find the sum of the tens, multiply that by 10, and so on and so forth. But let us see how we would do that. So I guess like the idea is you have 9 options for your first one, right? And then you have 10 options for your second letter, or second digit, right? So essentially that results in a total of 90 palindromes. So we gotta find the sum and then divide it by 90, and that's not even that much, huh? So I guess there are 9 options, and then for each digit there is like 10 other options, right? So you go from 1 through 9, right? And then each of these is going to show up 10 times, right? Right? Yeah. Right, right? Yeah, okay, okay. So these show up 10 times, and also like this is times 100 because in the like first spot, right, we have digit, digit, digit. And then we also know this is like going to match the first digit. So it's also going to be 1 to 9 times 10 times 100. And then the middle digit is going to go from 0 to 10 or 0 to 9, and each digit is going to show up 9 times, right? Because you're multiplying by 9. So you got 0 through 9 times 9 times 10, and not times 100 here because that's the ones digit. And we just solved this. Okay, so this is going to be 9 times 8, or no, 9 times 10 over 2 times 10 times 100 plus 9 times 10 times 10 over 2 plus 9 times 10 over 2 times 9 times 10, and then the whole thing over 90. Oh, I'm kind of covering this up. Hold on, let me move my camera. There we go. Very epic. Alright. Now you guys can see that's what the equation is, and now we just cancel stuff out and we should be in good shape. So this actually cancels out, that cancels out, that cancels out, and we are left with 5 times 100 plus 5 plus 45, which is 550. Very epic. Is that right? Let's see. Bruh. I like how the answers are just not showing. God dang it. Literally everything. Okay, let's go. Bruh, why is it so slow at loading LaTeX? Come on. There we go, there we go. Epic. Alright, number 2. Equilateral triangle ABC has side length 840, okay. 840, 840, 840. Bro, that's not a 4. Oh my god. 840, 840, and then ABC. Okay. So point D lies on the same side of line BC as A, so it's somewhere over here, and BD is perpendicular to BC. So it's somewhere over here, right? Over here, somewhere over here. Okay. And then we have line L through D parallel to line BC, intersects sides AB and, okay, so it's probably like over here a little bit, and like that, with parallel. And it intersects at, what, E and F? Okay. Alright, point G lies on line L, so this is L, such that F is between E and G, okay, so it's like somewhere here, and AFG is isosceles. Holy moly, dude, what? How did that even work? AFG. F is between E and G. Huh? Did I draw this wrong? So it's parallel to line. Okay, so BD is perpendicular to BC. Okay. And line through D, parallel to line BC, intersects AB and AC. Okay, so AB, that's E, F. Okay. Point G lies on line L, which is a parallel one. And so that F AFG, how is that oh, smart. I thought I was trying to do isosceles this way, but it is doing isosceles this way, okay. That makes a lot more sense. And then we got the ratio of the area of AFG to the area of BED. Okay, or BED. Alright, so this is D. 8 to 9, alright. So, we want to find AF. Alright, well that was a long problem to read, but that's okay. Let's see. So this is parallel, right? So this is going to be equal to that, and that's equal to that, right? And I guess this is equal to that, because it is the equilateral triangle, okay? This is going to be a 30, 60, 90 triangle, right? What else do we know? So this is, wait, so why can't D really be anywhere? Oh, I guess that just depends. Okay, so D could be anywhere, but we know that the area ratio is something, so we need to be careful there. Okay, so what is the area of this? That's like this length? Okay, so let's just say this is H, right? Or no, I guess this H makes more sense. H, okay, sure. And then this length over here is going to be 840 over 2, which is 420, nice, times root 3. So 420 root 3, or this is going to be 420 root 3 minus H, right? Okay. And basically H over 420 root 3 is going to be equal to this over, like, okay, so, well, okay, this is like a 30, 60, 90, so this is just going to be H over root 3, 2H over root 3 is this length, so this is 2H over root 3. Oh, and this is also like a 120-degree angle, so this is going to be divided by 2 times root 3 is H, right? And then this is going to be H over root 3, okay? So the area of this is just H squared over root 3, okay? So A of G is H squared over root 3, and then the area of this is going to be 420 root 3 minus H over, or over root 3 is that, and then you just multiply that. So it's going to be 420 root 3 minus H squared over root 3 over 2, so over 2 root 3. And the ratio between these two things is 8 to 9, so I'm assuming we're going to get an epic quadratic. Let's go, I love quadratic, bruh. Okay, so we got this, right? So we will, sorry, 420, right? And then we want to solve it. So A of G2, so this is smaller, right? So essentially this would have to be 9 times that, 8 times that equal. Okay, this cancels out, that cancels out, that becomes a 4. And now we just solve. So we get H squared minus, or sorry, okay, so I guess it's 9H squared, and then this is going to be 4H squared minus 4 times 840 root 3, right? H plus 420 root 3, or 420 squared times 4 times 3, okay. So now what do we do? That is the question. So this becomes 5H squared plus 4 times 840 root 3H, minus 420 squared times 4 times 3 equals 0. Okay. So essentially, if we like, what? So, what do we want to do? How do you even factor this? This is kind of big numbers. Well, okay, so you got like h squared plus like divide this by 5, which would give you, basically dividing by 5 is what happens if you divide by 10 and then or multiply by 2. So divide by 10 and then multiply by 2 is 4 times 168 root 3h, and then minus, that's gonna, it's still big though. Okay, 420 times 84 times 4 times 3 equals 0. Okay, and now could we finally get a number here? I don't think it's gonna be that easy, but we want 420. Yeah, I don't know how to factor this easily, bruh. it's kind of nasty, dude. Okay, maybe if we just like do like x instead of that, it'll be a little nicer, and then we could plug it in after. Try that. X instead of 420 root 3, we get like 9h squared equals 4h squared minus 8xh plus 4x squared, right? So that gives us 5h squared plus 8xh minus 4x squared is equal to 0. And then can we factor this nicely? So you get like 20x squared, right? And you want to make this into 20x squared. Oh, so that would be like 5h squared plus 10xh minus 2xh minus 4x squared. And that gives you like what, 5h times h plus 2x minus 2x times h plus 2x. Okay, there we go. That's nice. All right, so now we basically get that like h is equal to negative. Okay, so minus 2x. So it's either like 2x over 5, h is equal to 2x over 5, or h is equal to negative 2x. And because x is positive, this probably just means that h is equal to 420 root 3 or 840 root 3 over 5, right? Which is equal to 168 root 3. Okay, we're getting there. We are getting there. Okay, so essentially we got the height, and then we want to find AF, right? So this is 168 root 3. That means that this is just divided by 168 times 2, and that is equal to 336. Let's go. Very nice. Okay, that was kind of bashy, but it's okay. Is that right? Yes, let's go. Very nice. Alrighty, number 3. How fast? That was pretty fast, honestly. Okay, well, maybe not. Well, 10 minutes for the first two can't be that bad on an AIME. Usually time is not the biggest deal, though. It's usually just getting wrecked by the harder problems. Okay, find the number of permutations x1, x2, x3, x4, x5 of the numbers 1, 2, 3, 4, 5, such that the sum of the 5 products is divisible by 3. Okay. So, that basically implies nothing. Wait, well, it does it. Yeah, it doesn't really imply much right away. Well, we know, okay. So we know we have 1, 2, 3, 4, 5. So, okay, so we know 3 multiplied by anything. So wherever 3 is, it just like makes everything that's multiplied by it not even count, right? So it's like taking chunks, right? So essentially, okay, so let's just say 3 is here. Like the sum of the two to the left of it won't count, this one won't count, and this one won't count. So essentially 3 sums just don't count, right? And then the remaining ones are going to be like these two guys or these 3 guys and these 3 guys. Okay, so those are the sums that we want to work. Okay. So we need this to be divisible by 3. So we just need two triples. Okay, so basically 2 of them literally overlap, right? So essentially we want 2 numbers, right? Okay, so we can literally factor out 2 numbers. So let's just say it's like these 2 sums, right? So we factor out x1, x2 times x5 plus x3, right? So essentially we need the sum of these 2 numbers to be a multiple of 3. Like we need the 2 ones that are next to the 3 to sum to a multiple of 3, and then we're good. So yeah, so essentially like anything where the things next to the 3 sum to a multiple of 3 is good. So we can have like 3, 1, 2, 2, 3, 1, 1, 3, 5, 5, 3, 1. Nothing else works with 1, so we move on to 2, and that has to be 2, 3, 4, and that's it, or 4, 3, 2. And yeah, that's basically it, right? 4, 3, 5, and 5, 3, 4. Okay, so now we basically found all the like things next to 3 that work, right? So essentially, oh god, oh, that was kind of epic voice cracks, boys. Okay, basically what we want to do is, okay, so we can put the 3 anywhere, right? And then we could like multiply by how many are there? So 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 of these, right? So there's 5 places to put the 3, right? And then there's 8 things you could put next to the 3 on either side. And then the remaining 2, there's like, it doesn't really matter which way you put the remaining 2, so you just multiply by 2. Am I trolling? I hope I'm not trolling. I feel like that's right though. 80? It's kind of a small number, but it shouldn't be that big. So you do multiply by 2, right? Because the remaining 2, it doesn't matter what order you put, right? So, yeah, like 3 is the only one that's divisible by 3, right? Okay, so 5 times 8 times 2, that's right. Okay, you know what? Let's go with it. If it's wrong, then we gotta actually resolve it, but I'm pretty sure that's right, right? Is it? Is it? Bruh, please load the LaTeX, my guy. There we go. Okay, it is right. Let's go. That's kind of cool. That's actually a really cool problem. What the heck? That's crazy. Okay, I like that a lot. There are real numbers a, b, c, and d such that negative 20 is a root of x cubed plus ax plus b, and negative 21 is a root of x cubed plus dx plus d, alright? These two polynomials share a complex root m plus root ni, okay? Where m and n are positive integers and okay? Huh. So they share that complex root, which means they must have m minus root n, I as well, okay? So essentially, okay, well, let us see. So if we have x minus that and x minus m plus root ni, right? And you multiply them together, what do we get? That is the question. Let us try it out. Oh god, I hate FOIL. Okay, so x squared minus mx plus root n xi minus mx plus m squared minus m root ni minus root nx, or root ni x, plus root nmi minus n plus n. Okay, there you go. So essentially we just need to like cancel stuff out. This should cancel out here. This cancels out, and we are left with what? Does this not cancel out? Really? Oh, I guess it doesn't. So we get x squared minus 2mx plus m squared, right? Plus n. Okay. Nice. So essentially this times like x minus 20 or x plus 20, and if you multiply by x minus 20, both of them give like 0 for their x squared term. So let's try it. Well, let's call this a, and then we could special case it. So we get, well, we only care about the x squared term, so we get like ax squared, right, minus 2mx squared, right? That's it. Yeah. Okay. And that means that if our a is 20, x squared minus 2mx squared, or 20 minus 2m is equal to 0? What? No. The n has to matter too. Oh, so the other one is, okay. So, yeah, so 20 minus, okay, so m has to be 10 then, right? Because that's that. And then for the 21 one, we have 21, okay, we only care about the x term, which we want to be 0. So, in that case, we would have minus 2max, right, plus m squared x, and that's it. So, or m squared plus x plus nx, which basically gives us that negative 40, or sorry, yeah, negative 42 mx. Wait, what? Oh yeah, okay, so m also matters. So negative 42 mx plus m squared plus n is equal to 0, okay? Which basically gives us that if we plug in 10 from here, we get negative 420x. Dude, why are there so many 420s in this one, dude? Oh, that's epic. Well, I guess 21 is half of 42, so it makes sense. Okay. We got 42. Oh my god. This is confusing me. Okay, 100 plus n equals 0, and we don't need the x. So essentially that gives us m is equal to negative 320? No, you can't have that. What? No. Hold up. Right now. Oh, wait, I'm trolling. Yeah, 320, okay. N is 320. So we got m, okay, so 330 should be our answer. Let's go. I feel like I did that a bit fast, so we might be wrong, but let us just check. Yeah, okay, it is. Let's go. Epic. Okay, number 5. Dang, the second two took even less time. Okay. Problem number 5. For positive real numbers s, let tau of S denotes the set of all obtuse triangles that have an area S, and two side lengths of lengths 4 and 10. Okay, the set of all S for which T of S is non-empty, but all triangles in T of S are congruent is an interval A to B. Okay. Huh. Okay, this doesn't seem too bad, right? Well, okay, so obtuse triangle, you got a theta here, you got 4 and 10, and you want area S, right? So essentially the formula is 1/2 times 4 times 10 times sine theta, right? Is equal to S, which basically means 20 sine theta equals S, which basically means sine theta is equal to S over 20. So basically for it to be non-empty, you essentially need S over 20 to be less than 1, or less than or equal to 1. Yeah, so if it's less than or equal to 1, then yeah, so S has to be at most 20, right? Could it equal 20? Yeah, it could equal 20, which might be, okay, we might have to, yeah, the bound, I guess they might not be congruent at S, well, I guess there's only one thing that works at S equals 20. But shouldn't 20 work then? Wouldn't it be a closed interval? Okay, so let's say it's 20. Then, yeah, you just have right triangles. Oh, obtuse. Okay, that's why it's closed. Okay, so, yeah. Right triangle is not obtuse. Remember that. Hold up. That means that... What does that actually mean, though? Okay, so... The problem is that you could either... Oh, but it's always obtuse. How can you have non-congruent triangles? What? Shoot. Oh my god, the voice cracks. Jesus. Holy... Oh god. Oh my. That's so sad, dude. Oh, okay, anyways. Point is, I guess, that... Oh, so you could have an obtuse angle at a different angle is the point. Okay. Hmm. So, how do we... Okay, so definitely, like, an obtuse angle at theta works for all s is less than 20, right? So essentially we just need there not to be a acute angle, like, the acute angle should not result in an obtuse angle somewhere else, is what it's saying. So that's why your s has to be a certain size, right? Because the bigger your sine, the closer together your obtuse and acute angles are. So essentially we need to find where this is a 90-degree angle, right? And then everything above that would work. So if this is like theta, right? What would sine theta be? So you literally just like, okay, so the 90-degree, you do 100 minus 16. What is 100 minus 16? Math is too hard. 84? Yeah, okay. Epic. Okay. So essentially we got our sine theta is root 84 over 10. And that's what our lower bound, right? Because we want sine theta to be greater, or like greater than or equal to that, so that this other one doesn't work. Okay, so then our answer will just be 20. Okay, so 20 squared. Is this even... Hold up. Yeah, times 20. So sine is that, so you have to multiply by 20 to get s, so it's plus 2 root 84 squared. Which gives us what? 400 plus 4 times 84 gives us 320, 336, 736. Dang, there's a lot of 330s in this one. Okay, so 736 should be right. Hey, epic. 5 for 5 is pretty good, not gonna lie. I usually mess up like half of the first few. No, I'm kidding. But still, that's pretty good. Okay. Problem number 6. For any finite set S, let S denote the number of elements in S, okay? Find the number of ordered pairs A, B such that A and B are not necessarily distinct subsets of 1, 2, 3, 4, 5. That satisfy... Okay. Okay. So, you got like the product of... Okay, this is kind of... Okay, this is confusing. So, intersection times the union. Huh. Okay, so, I mean, let's just think about it as pi, right? Let's just say there's x ones that are only in A, y ones that are only in B, and z overlap. Okay, that's kind of confusing. Okay, so we'll have little a is how many are in A only, how many are B only, and then overlap is going to be O. So the first one is going to be A plus O times A, or O plus B, right? Then that's equal to, intersection is what overlaps, right? And then union is A plus O plus B. Okay. So these are equal. Let's try expanding that. You get AO plus AB plus O squared plus OB is equal to OA plus O squared plus OB, which basically means that AB is equal to 0. What? What? Hold up. Now hold your horses. Okay. Really? Seriously? I did not expect that. But that seems a bit about right. Did I mess up? No. Yeah. Okay, I guess that's right. So AB is equal to 0, which basically means that either one is completely in the other, or like one is completely in the other, basically. Okay. Like you basically need one to not have anything outside of the other. Okay, so how do you do that? So let's just say there's like 2 to the 5 ways to select a subset, right? And then, okay, well, okay. So you basically have B, okay, so let's say B is an empty set, right? So empty set works. Okay, so let's just do casework. So B is equal to 0, then this gives us one option, right? Both of them are empty sets. Let's see. Then you can do B is equal to 1. That basically means it's like 5 choose 1 ways to choose B, and then there is 2 to the 1 ways, right? Because it could be any subset of B. Like A could be any subset of B. Well, how to multiply that by 2 though? Oh. It could be both ways. Um, Okay, why don't we do like yeah, how do we case where it's kinda annoying. Well, okay, if it's the same thing, then you don't multiply by 2. So there's like 5 choose 1. So that like that's when they're both the same, you don't multiply that by 2. Or you could do one is a subset of other, so you multiply by 2, right? So either A could be a subset of B or B could be a subset of A, alright? Oh, I guess the right way to do this would be like 1, yeah, it's 1 plus 2, okay. Then B is equal to 2, yields 5 choose 2. And then if they're both the same size, that's 1, right? Like A is all of B, right? A equals B, that's one case. And then it just times 2 for the rest, right? So how many other options? So it's 2 to the 2, right? And then so that's 4 minus 1. So it would be plus 3 times 2, okay. Then 5 choose 3 times 1 plus 2 to the 3 is 8 plus 7 times 2. 5 to the 4 times 1 plus uh 16 15 times 2, right? And then right, yeah, okay, and then 5 choose 5 times 1 plus um what 1 plus 31 times 2. Okay, that's what we got. So we just sum this boys up. That's kind of nasty, but it should be fine. 5 times 3 is 15. Oh, let's do this. Okay, 15. 5 times 4 over 2, 10 times 7, 70. Okay, 5 times, okay, so 10 times 150. Okay, then 5 times 31, 155, and then 1 times 63. Okay, so if we just sum these boys up, we should get our answer. 305, 368, add in these guys, 385, 85, 31514. Okay, 453 is what we got. I don't know if that's right. That's kind of sus. Oh, shoot, we almost forgot to add 1. Bruh, literally on one of the AIMEs, I did like 121 plus 1 is equal to 123, and I, and like, that was the year I qualified for JMO, so I got so scared because I got way more borderline than I had to, just because I added wrong. But I think we caught this one. That's good. 454. Well, it might still be wrong, but hopefully it isn't. Let's see. 454. Hey, let's go, dude. What the heck? We're on fire. Epic. Let's go. Okay. How much time did that take? Oh, almost done. Okay. Well, I don't think we are going to finish number 7 by the end of today, so we should read it. Why not? ABC be real numbers that satisfy the systems of equations, blah, blah, okay. Oh no. Okay, yeah, I honestly don't like these kind of problems because I just don't know how to do them usually. Oh god. Let's see. There exists such that. Okay. Hmm. Okay, it probably involves like taking this first one squared and then subtracting out stuff. Wait, what? What the what? Oh, because there's only A and B there. Oh, okay, okay. Hmm. Yeah, this seems not super straightforward. Like, it's pretty easy to find. Actually, no, it's not. You don't have. Huh. Yeah, that's actually kind of tricky. Okay, yeah. We'll have to figure that one out next time. But it'll be rolling around in my brain. We'll see. Okay, well, thank you guys for watching again. I hope it was entertaining. You guys asked for the AIME, and I did the AIME, and it was kind of fun. Not gonna lie, dude. AIME honestly is my favorite math contest to do because like the problems are fun, they're hard. There's no multiple choice guessing nonsense, and it's like long. Dude, I don't like time pressure. I do bad under time pressure. But anyway, that's all I got for you guys today. If you guys enjoyed the video, make sure to leave a like and subscribe. Let me know what suggestions you guys have for future content. If you guys want some other live solves and that kind of thing. But other than that, I'm done for today. So see you guys next time. Alright, let's close the epic stream. Alright, bye.